Hello, in this lesson we're going to be speaking about the momentum of a rigid body. Okay, so for instance, if I have any shape, okay, the weirdest shape that I could possibly have, okay, something like this, okay? So if it's moving along in this direction and simultaneously it's rotating and then it changes direction, rotates this way and it moves up and down and all around, okay, if you're following my arrow, all of this. So you might be thinking, how on earth am I meant to work out what its momentum is going to be? Okay, so, and I'm reminding you that momentum is this, my P. So what is this going to be? It's going to be the easiest thing ever. It's very simple. It's simply going to be the total mass of the body multiplied by the velocity of its center of mass. Okay? And then, let's say its center of mass is somewhere here, then it doesn't matter if the body is rotating this way, whatever. We're just taking the center of mass as a point mass, and then we're just seeing how it moves and the velocity of it as it moves. Okay, so of course we also have to remember that our momentum is a vector quantity, okay, and so is our velocity. So let's give a example. So if here we have a ceiling, okay, this is a ceiling, and from the ceiling, okay, we have some kind of rod attached. Okay, the rod is rigid, okay, and it's of mass m. Okay, so I'm going to say it's of mass m, it's of length L, and it's moving like a pendulum, okay, up here, down, up to this side, okay, and let's say it's going at omega 0, okay, so also omega 0 is given to us, and we know this, and we're being asked to find what its momentum is equal to. Okay, so you'll notice that we have here circular motion. Okay, so that means that every section on the rod will be traveling at a different velocity, okay, to a different section. For instance, because this section is closer to the origin, so its velocity, its omega, will be significantly slower than the omega that is over here for this section. Okay, so now the trick here when dealing with a rigid body is that you don't have to consider this at all. Okay, so we can just rub that out, and all we have to do is look at the center of mass, okay, because that's the only velocity that we have to take into account. Okay, so if this is the center of mass, then we know that, bearing in mind that this rod has a uniform density, okay, so that means that its center of mass is going to be right in its center, which it will be at L over 2. Okay, so then all we have to do in order to work out our P is write down our mass, which we know it's m, and then multiply by my VCM. Okay, so the velocity of the center of mass. Now we know that velocity when dealing with circular motion is equal to omega multiplied by r being the radius. Okay, so here our omega is omega 0, and our r is going to be this distance, L divided by 2. Okay, so now the last thing that we have to do is just include in our direction. So we can just say that it's either moving in the theta direction, okay, if we're going according to polar coordinates, or we can say that at this moment in time specifically it's going in this direction, and we can say that that is the x direction.